Hi there, friends. Welcome to Lab at Home with the Museum of Life and Science. As always, we hope that you will help lead our program with your questions and thoughts and ideas in our moderated chat box. I've got my friend Caroline with me today. She is a Catalyst volunteer with the lab, and I am really excited to have her with us. She's going to be our chat box moderator today. So let's go ahead. Oh, we have some friends saying hi in the chat. Hello there, friends. Let's go ahead and get started on today's experiment. We're talking today about heat. We're talking about how it's winter outside, the weather is cold, and we're talking about ways to keep warm. So as we're thinking about ways to keep warm, let me ask you first, what is heat? This is kind of one of those questions where we deal with stuff like heat and cold and different kinds of things like this every day. It's such a huge part of our lives. But when you stop and think about it, you're like, wait, what actually is it? So if you'd like, you can tell me in the chat, what do you think heat is? Or maybe you could tell me, what does heat feel like? What does it feel like to touch something that's hot or warm? What does it feel like to touch something that's cool or cold? That's another thing that can be hard to describe. But tell me what you think of. What is heat? Also, heat keeps us warm. That's exactly right. That's kind of what gives us that warm feeling, is when something is hotter. We say that it is a form of energy. That's really good. It is a form of energy. And when we say energy, we're talking about the molecules that make everything up, right? So all around us, everything is made up of teeny, tiny pieces called molecules. And they're all kind of moving. And they're moving, they're vibrating in very kind of small ways, but in ways that have big effects on our world, right? The more that they are vibrating, the more that they're moving, the more energy they have. And that energy is often expressed by heat. Sometimes that energy is also expressed or kind of transferred, shown by light. Like if we're thinking about the sun is releasing a tremendous amount of energy, and it does so through heat, through thermal energy, and it also does so through light. So there's different things that happen when energy is released, and oftentimes heat is one of those things. So we're saying that heat is when all of the molecules, all the little pieces, are full of energy. And when things are cold, does that mean that things have a lot of energy, or they have less energy? What do you think? Yeah, exactly. So when something is colder, those molecules are slowing down a little bit, right? They're not moving as fast, they don't have as much energy, and that's what we would call cold, or having less thermal energy. This is a really great addition in the chat. When we're thinking about keeping warm in winter, when we're thinking about things like heat and cold, we think about a bear hibernating in its cave. So that's one thing we think of when we think of winter. How about if we're thinking about us keeping warm in winter, or any time when it's really cold, what do we do? Or really any animal, right? What do humans, what do non-human animals do to stay warm when it's cold? What do you think? While we're thinking about it, I have a really interesting question in the chat asking, in the Arctic, so where it's really cold, do the molecules move at all? That's such a good question. Those molecules are still moving. The only time when things are cold enough for molecules to stop moving is we think it's kind of an idea. We say that it's at a measurement called 0 Kelvin. Now, when we measure temperatures on Earth, we use Celsius, we use Fahrenheit to measure the temperature. But if we're talking about really high or really low temperatures, especially in space, scientists might use a measurement called Kelvin. And when things are at 0 Kelvin, then that means the molecules are not moving at all. But it's not something we've observed yet. We don't really know. We've never observed something in 0 Kelvin, so it's kind of a theory, but it is a really interesting idea. Great question. There's still a bit of movement in the Arctic, even though those molecules are slowed down. Awesome question. So back to the question of what do we do to keep warm in the winter? I have some friends in the chat saying that we wear jackets. Yeah, we bundle up. I like this. So I have today my little fleece on. This is something that I do to keep me warm. So that's a really good way to do it. What if you don't have a jacket? What if you're a non-human animal and you want to stay warm? What might you have, or what might you do? What do you think? What do you think? If we don't have access to a nice fleece, right? If we don't have a nice coat, we might have something else on our bodies if we're a non-human animal. How about fur? So we are humans, right? Are mammals. So we do have hair on our bodies, but humans don't have a lot of hair on our bodies compared to other mammals. So other mammals, like you might think of a dog or a cat, or we were talking about bears earlier. This is a really good thought. A lot of animals do hibernate. There are different behaviors, like this is a really good addition. Sometimes there are behaviors like eating more, which are kind of a response to the cold. I love that idea. And we're going to kind of talk about why those behaviors can be a response to cold. Right after we're kind of talking about things that physically keep an animal warm. So our bodies, as mammals, we are warm-blooded. That means our bodies produce heat. So go ahead and I always touch the back of my neck because I can always feel that that's pretty warm, even though my hands are sometimes cold. I can feel that my neck is warm. A lot of times my face, right, is warm because my body is producing heat. When I eat food, right, my body starts to break it down, metabolize it. One of the things it does with it is it helps keep my body the same temperature. I'm actually going to check my temperature really quickly using this infrared thermometer. So this is going to use a laser to check my temperature. I checked it earlier and it wasn't perfectly calibrated. It didn't show my actual temperature because I took my temperature this morning when I came to work and it was normal. So this one is not my accurate temperature, but it will still show us changes in temperature accurately. So I'm going to go ahead and take my temperature right by my hairline, and it says 97.1, which is not exactly my temperature, but we can at least tell that my forehead is warmer than, say, my arm, which is only 90.5, right? So I'm going to be using this to help us tell temperature. You all are going to be using, and I am also going to be using our senses to help us kind of do some experiments about ways that we can keep warm in something that's really cold. So I just wanted to see, is anyone out there doing the experiment with us today? That's where we're going to move on to next. We're going to do our experiment where we're going to see if we can keep warm in the face of something really cold. So I have got a couple supplies here. I'll show you on Experiment Can. Oh, it sounds like we have some people who are doing it. That's awesome. I have a big bowl of water, and I might even go ahead and switch to Experiment Can. So I have this big bowl of water here, and I have some ice cubes in it because I want to make this really cold. In fact, I wanted to make this even colder, right, by doing something kind of cool to it. This is optional. You don't have to do this, but I wanted to see if I could make it a little bit colder. So I have here some salt. This is just regular table salt. And I'm going to use it to make my water colder. So what salt does is it makes ice melt, but it's still cold. So it keeps ice from forming, but allows the liquid state of water to remain cold. So I'll check the temperature of this. And let's see, we're saying that this water is about 45.6 degrees Fahrenheit. Now I'm going to add a little bit of salt. If you're doing this at home, you can add your salt now. I'm going to make some really cold water. Since this salt will help the ice melt while still keeping it really cold, the water really cold, it'll be even colder once I stir in some of that salt. So I have my cold thing right now. My warm thing is going to be my hand. And I'm going to be covering my hand with some different things. I'm also going to drop my spoon in the water, which I can confirm is quite cold. So we've got our nice cold water, and I've got a bunch of different things with me. And we're going to kind of use those different things to make a mitten for my hand or for your hand by putting different materials in it, right? So I've got some different materials that I'm going to use to help trap that heat. I've got some packing peanuts in here. I've got some cotton balls. And if you're using different things at home, I'd love to hear some of the different things that you are using. I'm going to try out some of these really thin cloths. I'm interested to see how those work. I've also got some pebbles. Whoops. I've got some pebbles, and I'm interested to see if those make very good mittens. That's one I haven't tested before. I've got some other things here, like some tin foil. I've got some bubble wrap. Ooh, this is a really good question. Thank you, Caroline, for mentioning this one. When we're talking about heat flowing, so heat moving, or the amount of energy changing, we're saying it flows in a certain direction. It flows from hot to cold. So things that are hot will tend to get colder, right? Their energy will kind of tend to move away from it rather than something that's cold suddenly becoming hot, right? So that's a really good question. We're going to be messing with that flow of energy. We're going to be using some of these different materials that I have shown you as different kinds of insulators. So an insulator is something that's going to keep the heat of my hand from transferring to the very, very cold water. So first what I'm going to do is I'm going to check the temperature of my water. Ooh, and actually it did get much colder. This says that it is 38.6 degrees Fahrenheit. So that's pretty cold. I have some pretty cold water here. If I check the temperature of my hand, it says my hand is about 88.4, right? What I'm going to do is I'm going to see what happens when I stick my hand into this bag and into the water, right? I'm going to try it without my supplies first. I'm just going to see what happens if I don't have anything else in here. We said my hand was about an 88.4. Now I'm going to put it in the water. You're welcome to do this part as well. Now the reason I'm putting it in a bag, ooh, that's nice cold water. The reason I'm putting it in a bag is because I don't want to get my hand wet, but I want to make sure that I am feeling the cold of the water. Ooh, and I definitely am. I take it out of the water. I don't know if you can see, but my fingers are even kind of pink. A lot of times that happens because it's kind of trying to conserve warmth. My blood's trying to conserve warmth. So I'm going to take my thermometer and I'm going to test how cold my hand is now. So this says my palm is 84.7 degrees Fahrenheit, which is definitely less than 88. Let's try my fingers. They feel colder. It says my fingers are at 68.2, right? So there's definitely different degrees. My palm is still warmer than my fingers, but overall, my hand got a lot colder when I put it in the cold water. That makes sense, right? What I want to see now, is there anything we can put in this bag to trap my body's heat and keep it from losing energy in that cold water? So what I'm doing is I'm kind of getting my hand warm again while we're thinking about it. This is an interesting suggestion. We have someone suggesting oil. Now I don't have oil, but I do have something that we're going to try as our very, very last thing. And we're going to try this object last because it makes a little bit of a mess. But that's a good thought. Hold on to that one, my friend. Let's see. I think I'm going to try either packing peanuts or cotton balls first. What do you guys want me to try? What do you think? I'll do whichever one you guys want me to do. Cotton ball, packing peanuts. We've got some votes for cotton. Yeah, it sounds like we have 3 people who want us to use the cotton balls. Ooh, there's another person. So what I'm going to do, and what you're welcome to do along with me at home, is I'm going to take one of my materials. I'm going to be using cotton balls. And I'm going to try to create a mitten for myself. So what I'm going to do is I'm going to put some of my cotton balls into my bag. Because remember, I'm going to stick my hand in here and it's going to act as my mitten. So let me ask you, we're talking about keeping my hand warm is the cotton itself warm? Does this make heat? What do you think? No, I would agree with you. It doesn't make heat, but it does trap it, or our thought is anyway, that it might trap heat. So we're going to see if this traps my heat. What I'm going to do, and if you're going to be testing yours out as well, what I'll have you do is put your hand in your bag, whether it's a Ziploc or I think I also recommended you could use a grocery bag if you wanted to. That's another good one. Is we want to have our material near our palm. So I'm palm down, facing my material, because I'm going to be testing the temperature of my palm before and after. So we have one person in the chat who's using clean socks. That's so interesting. Can I ask, are you putting it on your hand like a mitten, or are you kind of stuffing it into your bag? I'm curious to know. What I'm going to be doing at least is putting it on top of those cotton balls. While we're thinking about that, what we're going to do is I'm going to take the temperature of my hand, right? Because I'm taking it before and after, and you don't have to have a thermometer, right? Because your body is really good at telling differences in temperature. Oh, this is really cool. So our friend who are the ones who are using clean socks, one of them is using them as a mitten, and the other one is using it kind of packed around. That is such a good experiment. I love that idea. Okay, so if you don't have an infrared thermometer, right, you don't need one because your body is really good at telling whether something is hot or cold. So I guess the idea is we want to kind of feel our palm right now, and we're going to put it in the water and see, does it become cold really quickly? Does it stay really warm? And that's kind of what we're judging, right? I'm using the thermometer to help me, but we can judge whether or not it's warm or cold by ourselves. So let's go ahead. I'm going to use my thermometer to test my hand. It says my palm is at 86 degrees Fahrenheit. I'm going to test my mitten. So there's my cotton balls. There's my hand. And I'm going to make sure that there's no water that's going to get into my bag. But I'm going to just stick my hand in. And if you're doing this at home, you can go ahead and try it out now if you're ready. And I'll tell you what I'm feeling. I'd love to know what you all are feeling. I'm feeling that the top of my hand is still really cold. I'm going to stir it around so I can feel extra cold. Ooh, the top of my hand is very cold. But the bottom, it took a minute for it to get colder, right? So it felt warm for a minute, and then it did feel kind of cold eventually. But I felt like it trapped my heat for a little bit longer. I'm going to go ahead and test my palm to see. At the very center of my palm, it was about 84.5 degrees. So it did get cooler, right? But is it as cold as the unprotected part of my hand? No, this is 60 degrees Fahrenheit. So this unprotected part of my hand got much colder than the part that was kind of protected by the cotton balls. I'd say that the cotton ball was a pretty good insulator. It kept my heat trapped. I'm going to try something else. I think I'm going to go ahead and put my cotton back. And let me know what your test results are. I'd love to hear about it. I think I'm going to try something different. When I think about things like how animals stay warm, I think about fur, right? And I think about maybe even feathers. I don't think about anything that's hard and shiny and pointy like tinfoil. I think of something warm and soft. The cotton ball being warm and soft reminded me of an animal's coat. So I thought, yeah, it's pretty likely that this one will help keep me warm. What do you guys think about tinfoil? Do you think that one will help me? I'm going to go ahead and take my measurement. So right now I'm at 86 degrees for my palm. What I'm going to do is kind of make myself a mitten. I'm going to use 2 layers of tinfoil. Kind of wrap it around just my palm. Then I'm going to stick it in my bag so it doesn't get wet. We have some hypotheses in the chat. We have some scientific guesses saying that some of my friends do not think that the tinfoil will protect my hand. Let's find out. I'm going to stick this in right here. Now that's really interesting. again, I feel the tops of my fingers, the unprotected parts, getting really cold. But I was kind of surprised to feel that the tinfoil's not getting cold as quickly. Now, as I'm keeping it in here a little bit longer, I can tell that it's starting to cool down, right? It's starting, we would say, to lose energy. So it's not that it's keeping my hand perfectly warm. I bet my hand will still be a little bit colder. But I don't know, I think this one might have been a pretty good insulator. So this is saying that my temperature is, whoops, it took the temperature of the water instead of my hand. This is saying that my palm is at 87. And I'm trying to remember what my measurement was before. I'll have to keep better track of this. But I feel like my palm may have actually warmed up. The heat of my body helped warm up my palm. And it was, that heat was captured pretty well using this tinfoil. That is so interesting. That's so interesting. So we think tinfoil might be a pretty good insulator. Let's try something else. Oh, that's interesting. We have someone in the chat who tested tinfoil and that made you feel colder. That's so interesting. Can I ask, did you use 1 or 2 layers of tinfoil? I don't know if it makes a difference, but I'm curious to know. What I'm going to do now is, while we're thinking about that, I'm going to go ahead and take my temperature right now. Whoops. It's 84 right now. It kind of cooled down because I was putting my fingers against it. So I'm going to warm my hand up before I take my temperature. Caroline, thank you for reminding me that it was 88 before. So it did get a tiny bit warmer. Interesting. Our friends who used tinfoil said they used 1 layer and that the metal felt cold on their hands. I felt that too when I was touching it. Like I felt like it kept me warm for a second, but then it felt like I was touching cooler tinfoil. Interesting. That is such an interesting idea. I'm going to try a different one that I'm not so sure about. I've got some rocks here. What do you think? Do you think that rocks will be a good insulator? Do we think rocks will help keep me warm? I'm interested to find out. So I've got my rock mitten right now. I'm going to have that protecting my hands. We have some guesses in the chat saying, I do not think that the rocks will help. I'll go ahead and take my palm temperature. It is at 83.4, so it's still a little bit cool. That's okay. We'll see if it gets even cooler. So what I'm doing is I'm making sure that the rocks stay underneath my palm. And I'm going to test this out now. And as soon as I put it in, it feels pretty darn cold. Now what's interesting is the rocks were cooler when I first touched them, and now they feel warm compared to the water, but I can definitely feel them cooling down quite quickly. We had a guess in the chat that the rocks will make it even colder. Let's find out. Let's see. So this is saying the center of my palm is 85.6. Oops, we'll give it a second. And that I'm at 54 at my fingertips. Oh my goodness. So I think that it didn't really change my palm temperature very much. And I think you guys were right, it was not a very good insulator. Those rocks were not very good at keeping my body temperature in. I'm gonna go ahead and pour my rocks into my bucket here so that I can try out something else. I think I might try, I know. I'm gonna try some marshmallows. It sounds like some of us are testing plastic bags and those are working really well. That's so cool. I also had some plastic wrap that I was gonna try, but I'm really interested to try some marshmallows. What do we think? Will a marshmallow mitten help me out? I'm very interested to find out. Ooh, it sounds like a towel worked for one of our friends and the rock did not. I would agree with you. I don't think my rock worked very well. I have one friend in the chat thinking that, yeah, marshmallows will help me. That's an interesting idea. What I'm going to do is I'm going to put a little bit more marshmallow in here. Marshmallows are interesting, right? Because they are definitely fluffy like a cotton ball, or rather they're kind of soft like a cotton ball, but they're not super, they're not made of like fibers. I guess we don't think of them as being very fluffy, just kind of squishy. So I wonder if that squishiness will still help keep me warm. All right, I've got plenty of marshmallows in here. I'm gonna make my marshmallow mitten. I'm gonna go ahead and I'm gonna put my hand in. Oh, I didn't measure it before I did, but that's okay. I'm just gonna see if I can tell by my senses. So like before, right, with most of my things, the top of my hand gets quite cold immediately. I'm feeling like, yeah, actually those marshmallows are helping me out. Now, a little bit like the tinfoil, they're starting to cool down, but I don't know. I think that my marshmallows are helping keep me a little bit warmer than the tinfoil, right? They don't feel as cool as quickly. So I think that the marshmallows actually did pretty good for me. I know we didn't measure before, but I might just test out because my palm does feel pretty warm. My palm's at 85, which for my palm during this experiment is fairly warm. That's really interesting. My marshmallows helped me out, and I think that can be explained by something in the marshmallows, right? Marshmallows have lots of air in them, right? So we know that they're squishy. So they have little pockets of air. And while air itself can't keep you warm very well, if there's a trapped pocket of air, then that air kind of traps the heat, right? So if air is in a little pocket, like it is in this marshmallow, there's kind of all these tiny little, almost like pockets or bubbles of air inside of here, then they do a good job of trapping that heat. I had someone ask earlier, does an igloo help keep you warm? Which is such an interesting question. An igloo, even though it's made of snow, it does that thing where it traps air, right? Especially if we have our blocks are made out of packed snow. There's a lot of little air pockets in there. And those trapped air pockets do help contain heat. So there are lots of other things that I could test. I think we'll see if maybe I have some time for feathers, but I want to try this last one. I want to try one more with you guys. Dumping out my marshmallows. Earlier we were talking about different behaviors. Let me switch to my face cam here really quickly. Earlier we were talking about different behaviors that animals and also human animals, right, do during wintertime. Is a lot of times we're thinking about eating more, and that being something that can maybe help keep us warm. I think I saw someone mention too, eating more before hibernation, because when we are eating more, right, that kind of helps, like, of course, keeps our metabolism going, keeps our metabolism having enough fuel to keep us warm. It might have to work a little bit harder, right, if it's colder around us to keep our temperature warm. And the other thing that especially certain animals that live in the Arctic and Antarctic have is a really special layer of fat. Now, they have to fuel that fat with a lot of calories, so they have to eat a lot to make sure that their bodies are storing that fat, which itself stores energy. This special kind of fat has a name. Do you guys know what the name might be? We're thinking about different animals that have this type of fat, include like walruses, whales, even have this type of fat. Do we know what it's called? Ah, exactly, my friend, it's called blubber. So blubber is a really special kind of fat that does a lot of interesting things. It's really good at trapping heat. And it also has the ability to, if we have an animal who, let's say this is my fin, and it's covered in blubber, just like my skin has blood vessels that are inside of it, right, because they're fed by my blood supply. The blood that would move through the blubber has the ability to contract, to kind of get a little bit smaller when it comes in contact with cold. So it helps keep warm in that it traps heat. And it kind of keeps our blood from cooling down, I guess we could say, or not our, but an animal with blubber, it helps keep their blood warmer because it is contracting. It's keeping that blood a little bit closer together and not touching the cold water as much. So I don't have any blubber, but what I do have is some vegetable shortening. So this stuff is a lot like Blubber. It kind of looks like ice cream in this light, but it's different kinds of plant oils, like soybean oils and palm oils, and it's really goopy. It's similar to lard, right, but this is from a plant source. And this is going to act as my blubber, because it is a type of fat. Now, it's not blubber fat, but it is a type of fat. What I'm going to do is I have put some of that shortening, that vegetable shortening, into a different plastic bag, and I'm going to stick my hand in there, and I want to see if it keeps me warm inside of my water. So what I'll do is I'll take my temperature in my palm. Looks like my palm is at about 82. That's okay. I am going to go ahead and put on a glove because I don't want to get all of my blubber all over my hands, because I still have to press buttons on the computer. But I am going to stick my hand in this very this very kind of like goopy fat, and it's going to feel interesting, I think. So here's my blubber mitten. So you can see that I'm sinking my hand into that pretend blubber, and it feels kind of cool. The shortening itself feels a little bit cold to my hand, so we'll see if that changes anything. But I'm going to go ahead and I'm going to stick it into my water. I'll go ahead and switch to my experiment cam here. I want you guys to guess. Do you think that that my pretend blubber will do as good as real blubber? What do you think? You have some guesses that yes, it will. Now that now that it's kind of warmed up from my hand, it doesn't feel so cold, so I gave it a little bit of a chance to kind of warm up. And now I'm going to stick it in the water. Here we go. Well, again, I noticed that the top of my hand feels pretty cold, but actually some of this, the top of my hand, I can tell where it's protected by the shortening on top, right? There's a few blobs on top, and I can actually tell where that's kind of protecting me from the cold. Because I'm moving my hand around. Yeah, and I'm kind of feeling like it's doing a pretty good job. Now, I do feel it start to cool down. Yeah, it's definitely starting to cool down now, so I bet it will make the surface of my hand still feel kind of cold when we measure it. But that was really interesting. It didn't feel like just sticking my hand into cold water, right? It didn't feel like doing this, which is still very cold. So it did protect me somewhat, but maybe not as well as an animal with blubber's blubber would protect them. I'm gonna go ahead and put it right back up to my face cam. So my friends, we have tested a lot of different kinds of insulators today. Some of them worked really well, right? I found that the cotton balls worked really well. The marshmallows worked really well. I found that the rocks did not work very well. And I thought the tinfoil was kind of somewhere in between. The blubber, I think it did okay for me. I think mostly it just made me very goopy. Oh yeah, and let's check that. We had a question in the chat. What is the temperature of my palm? My palm is 84. So it did get a little bit of a chance to warm up, right? It made sure that it wasn't too cold. It's definitely warmer than my fingers, which are at 58. Yeah, so it definitely made my fingertips were a little bit colder, my palm a little bit warmer. This is awesome, my friends. We are at time today. Thank you all for staying after a little bit. I get so excited testing all of these different things. I would encourage you to keep testing at home. And if you test anything particularly interesting, like I know I'm gonna test some feathers after we're done with this one, and I'm interested to see if they work, be sure and let us know. You can always send us an email, or if you want to put it on social media, you can always tag the museum and #LabAtHome. We would love to see what kind of cool stuff you're doing. For now, that is our lab at home. Next week is going to be Little Lab, and our Little Lab is going to be exploring different kinds of rocks and minerals. And then the week after that, it will be Lab at Home again, and it's going to be a really special holiday Lab at Home that I will tell you all more about in our post-lab email. Thank you all so, so much for an awesome Lab at Home today, for all of your amazing questions and thoughts and ideas. I hope you'll continue testing heat and cold, because this is a really easy experiment to do at home or anytime. So I'll see you guys next time. Thank you so, so much for being here. I really, really appreciate you all being here. Yeah, thank you. Thanks, friends. I'll see you later.